Okay, so this is a third video on resolving forces, and in this case we're looking at situations which are in equilibrium, so the overall force in any direction is equal to zero. So there's no resultant force, so the resultant force is equal to zero. Force equals zero. Equals zero. Okay, so we are now going to actually do a question which is much more involved with four forces, and we've got two unknowns, P and Q, and the problem is to find those up. And what we do in these situations is typically set up two equations, a resolving horizontally and a resolving vertically equation. Resolving horizontally, again, we can see that the horizontal component of this force here is P cos 40. That's the P force there, that's P cos 40. And that's going in the positive direction. That then, we can see that the 1 Newton force isn't horizontal, neither is the 2 Newton force, so they don't come into the horizontal equation at all. Then take away Q cos 55. It's cos because, again, it's next to this marked angle there. Okay, and that's equal to zero. Or alternatively, you could just say left equals right. P cos 45 equals to Q cos 55. You can go straight to this if you prefer. One force, forces this direction have to counteract forces in this direction if it's in equilibrium. It depends which way you want to think of it. So there we go. So that's resolving horizontally. Resolving vertically, right, now all four forces are going to come into this. We've got the 1 Newton force going upwards. That's that force. There's no horizontal, so it's just 1. Now this one here, the P thing here must be P sine 40 because it's going away from the marked angle that we have. So that's plus P sine 40. Okay, plus P sine 40. And then again, this one's away from the marked angle. We've marked 55 there. So this component here is Q sine 55. And again, it's positive because it's going upwards. So it's Q sine 55. And that, and then we've got the force downwards, which is equal to -2. And that equals to 0. Okay, you may prefer to just go straight to the, just say forces up. That's these three equal to the forces down, which is this one here. In which case you go straight to this equation, which is P sine 40 plus Q sine 55 equals to 2 minus 1, which is 1 Newton. Okay, so we actually have a simultaneous equation here. So I'm going to do that by substituting, because from this equation here, we have that P equals to Q cos 55 over cos 45, which is equal to 0.749 Q, but I've actually stored that in my calculator, the exact or more precise measurement of that in the calculator, or we can alternatively do algebraically all the way through. So then what we can do is we can substitute that into this equation here. So let's call this equation 1 and this equation 2. So sub into equation 2. And then that comes to Q, this bit here will come to Q 0.749 Q. That's the P, which we'll replace times sine 40 plus Q sine 55 equals to 1. If I take q out as a factor there, 0.749 times sine 40 comes to 0.841 up to 3 significant figures. But again, I've stored all this on the calculator. Plus sine 55, which comes to 4 significant figures, 0.819 equals to 1. So that gives me Q equals to 0.769 newtons. And when I substitute Q back into P there, 0.749 times by 0.769, I get P is equal to 0.576 newtons. Okay, now I want to do an example which is on an inclined slope, or where we're not resolving in horizontal and vertical. We're basically kind of tilting the axes, if you like. So we're resolving in kind of up the slope or perpendicular to the slope, and we'll see this plenty of times where we're resolving at an angle because it's more convenient to say. We will see things where something's resting on an inclined plane and that type of thing, in which case it's more convenient to resolve parallel and perpendicular. So resolving, let's do up the plane first. Again, let's look at the components individually. We've got 4 forces here. We've got the 5 Newton force there. We've got a P force there. We've got a 2 Newton force, which isn't going to be come into the up the plane because it's perpendicular to the X. So this one's not going to come into our parallel equation. And we've got the 8 Newton force. So up the slope, we've got P cos alpha. Cos alpha because it's next to the angle that I've marked here. So that's P cos alpha. And then we've got let's mark this angle in here. With a little bit of trigonometry, we can see that this is 90 minus 30, so that's 60. So let's mark this angle as 30 degrees there. Okay, so the component of the 5 Newton force down the slope is 5 sine 30, but it's minus because it's down the slope. So that's minus 5 sine 30. So that's minus 5 sine 30 down the slope. So that's why it's negative. And we've also got the 8 Newton force down the slope because it's down. And again, doesn't need to be resolved. Well, it doesn't need to use trig. It's already going in the X direction or down the plane. So that's minus 8 equals 0. Again, you might prefer just to look at forces this way, counteract forces this way. In which case you're just going to get P cos alpha. You're just going to get a rearrangement of this basically, which is 5 sine 30 plus 8. Okay, that's the resolving parallel equation. Resolving perpendicular in this direction. Again, we're going to, let's look at this force here. We've got P, but this time it's P sine 60. Or sine alpha, so that's P sine alpha because it's away from the angle I've marked. The angle I've marked there, I've got all this space here, so it's P sine alpha. Okay, and then I've also got the 2 Newton force. Let's rub some of this off now. I've also got the 2 Newton force going upwards, so that's plus 2. It's going upwards, it's positive. We don't need to use trig on it because it's only going in the y direction. It's going bang on in the y direction. The 8 Newton force doesn't come into this equation because that's going in the X direction down the plane or down the slope. So that's not coming into this equation. But the 5 Newton force is, let's mark this again, 30. Now this time it's next to this marked angle here. So that component there will be 5 cos 30, and as we can say, contrast that to the one we found when we were doing work in the other direction. It's 5 sine 30 down the plane there. So this is 5 cos 30, but it's minus minus 5 cos 30, which is equal to 0. Right, okay, so what we can do is then, again, we might just go straight to the rearrangement of that. Forces one way give you the forces the other, but it gives you P sine alpha equals to 5 cos 30 minus 2. So here we go. What we can do is we can divide these two. So we have P tan alpha is going to be P sine alpha over P cos alpha. So that's going to be equal to this, or the other way around, this divided by this. So that's 5 cos 30 minus 2 divided by 8 plus 5 cos 5 sine 30 plus 8. So that comes to approximately 0.222. And it's so that if we inverse tan that, we get alpha equals to 12.5 newtons, 12.5 degrees to 3 significant figures. And then we can also substitute that back to P. We can substitute that back into either of these to work out what P is. We can say that P cos 12.5. Remember, I'm using exact values here, or stored values rather than the rounded values, equals to 5 sine 30 plus 8. And if I work that out, that gives me P is equal to 10.8 newtons. Okay, so that's resolving vertically, horizontally in equilibrium situations, which we're going to see a lot of. In the next video, we'll be going on to much more kind of cases where we're naming forces. Okay, we're naming forces and working with that after doing, tensions and reactions and various things. But that's to come in the next video. Okay, bye.